So now let me just introduce our last speaker. So we usually save the best for the last. So he's Khaled Boughanmi. He graduated from the Columbia University at marketing, and he joining the Cornell University this fall as an assistant professor of marketing. So he's an expert in data-driven marketing and again, empirical model, and he's working on a very interesting topic, and today he will talk about dynamics of musical success. Using the data, we predicted what kind of music we would love. So, okay, Matt, thank you.
Yeah. Well, thank you very much for having me here. I apologize, I'm the last talk, but yeah, it's the last talk, right? So today I will be sharing with you some of the work that I've been doing at Columbia. It's a joint work with Assam Ansari and Rajiv Kohli, Dynamics of Musical Success. So music is a very important product for humanity. We have invented music a long time ago. It defined us as, it defined our civilizations, and it defined our history. But beyond the fact of being an important cultural product, music is an important economic product. The revenues of the music industry are about $17 billion, but also music is a good that is consumed a lot. 83% of the American consumers think that music is the second most popular media for them after terrestrial TV. And also Americans, they tend to spend lots of time consuming music. 162 minutes a day of music consumption. That's about spending 10% of your life listening continuously to your music. That's about 8 years. Music is also a very particular product. Usually we don't consume one song, we listen to a collection of songs. We have been doing it over the last 50 years via listening to albums that artists have been releasing. Nowadays, with the emergence of new digital platforms, the playlist or the concept of playlist has emerged. And actually, some statistics show that 48% of the entire listening to music is via albums and playlists, and playlists are nowadays taking over albums, with about 50% of all listening on Spotify is to playlists. We can also think about albums as playlists that are constructed by artists. They are the most sensible forms of playlists. There is a musical and an artistic experience that an artist wants to share with you. However, the act of creating these compilations of songs is a very difficult task. Why is that? It seems that 11,000 albums are released annually by major labels. However, less than 10% of all these albums actually cover the costs of their productions. And the cost of a production of a single album, they tend to be very high, about $400,000 to produce a single album. And for major artists like Adele or Beyonce, these costs can reach to like millions of dollars. Why is this task of compiling songs and creating albums a difficult task? It happens that music is an experience. When we listen to music, we go through different emotional states, and there is an entire balance of an artistic experience that an artist or a DJ creates. The BBC Music says it better. It says that making an album isn't just a question of getting together a bunch of songs, whacking them out as painlessly as possible and hoping for the best. No, there is an entire artistic idea around the compilation of these different songs into these listening sessions. So in this project, I will try to understand this musical experience from two perspectives. First, I will try to understand the perceptual aspect of music, how consumers think and perceive about the music that they listen to. And also, I will try to understand the experience that is conveyed in the musical content itself. By musical content, I mean the music itself. So we will use machine learning techniques in order to dig into the music. I will also try to understand the acoustical balance that is associated with the success of a particular album. As I said before, an album is not just recording songs and just putting them together. There is an entire musical idea behind the construction of a song. Music is also an art or a product that has evolved over the years. Music of the 70s is very different from the music of nowadays. So how can we capture how music has changed over time from these experiential aspects? To give you an idea about this, I compiled a very short compilation that shows the evolution of songs. And I will show you from this what I'm trying to do in this project. So in the 60s, for example, the music was more melodic. The 2000, I don't know what happened, but then the 2010s came, and then we find the return of the diva. There is Adele. Music is more sad, it's more soothing, and so on and so forth. In this project, I will try to capture these aspects of the musical experience, and then I will try to construct different playlists that could appeal to different types of people. For example, there is a very famous paper in marketing by Maurice Holbrook where he shows that we actually like the music that we grew up listening to. And that's why we don't like the same music that our parents like, or we don't like the same music that our kids like. So here I will try to use those understandings from the musical experience dynamics and try to construct new playlists that could appeal to different people, or also help artists compile new albums that could be appealing to nowadays audience. So, yeah. All right. To show you where I'm heading with this talk, I collected data from different online platforms, mainly what we call standard covariates, like the genres, or any variable that anyone could, or any analyst could have collected. We also collected sound data that describe the musicality of different songs, and textual data in forms of tags. These are texts that consumers use to describe the music that they have in their collections. And then we built a Bayesian nonparametric model, or a machine learning model that combines all these data modalities and correlate them with the success of different releases over the years. I will first tell you about the data that I collected. First, the measure of success. What makes an album a good album? Ideally, I could have used the sales of albums, but these data are not available. So I used the Billboard. The Billboard magazine is actually an American magazine that publishes weekly charts of the best-selling albums. I collected 54 years of data, from 1962 to 2016, and I used the year-end score to say which album was the best album for a particular year. The construction of this year-end score goes as follows. There are, let's say, about 52 weeks in a year. Each week, the album that charted as #1 gets 200 points. The album that charted as number 2 gets 199. The album number 3, 198, and so on and so forth. If at the end of the year, we would sum up all these numbers to come up with the album that has the highest year-end score. In other words, the best album is the album that remained #1 for all the weeks of the year, and the worst album would be the album that only appeared for 1 week at the last position. I also account for albums that never appeared on the charts, because those are really bad albums that never made any popular success. So this is my measure of success. And as you can see, it actually reflects more or less great sales of albums. For example, the album that has the highest year-end score is Thriller of Michael Jackson. And indeed, it is the world best-selling album of about 60 million copies worldwide. For my standard covariates, I collected genres. These are the genres that are contained in my data set. There are about 15, and we see here that rock music is the most representative genre the genre that is the most produced in the United States. I also collected and computed marketing and production variables like major or minor label. For example, you take a label like Columbia, they tend to have lots of resources to market their albums, while small indie productions, they don't have as much money to make marketing. I also have a measure of artist superstardom, the number of artists that are featured in an album. You take Jay-Z, Jay-Z has his own groups of fans. Beyonce has her own groups of fans. They release an album together and suddenly they are appealing to a broader audience. And I also account for the number of years an album appears on a chart. For example, you take The Dark Side of the Moon, it stayed for 15 consecutive years on the charts. So all of these are standard covariates. Anyone could have, or any analyst could have used these. The innovation comes here. I will be using acoustic fingerprints in order to account and capture the musical experience. Acoustic fingerprints are actually variables that are produced via machine learning and by a software called the EcoNest that is used by Spotify. And these acoustic fingerprints are actually 14 measures for each of the songs that is contained in each of the albums that I have in my data set. There are features that describe the musicality of a song from a theoretical musical description. For example, the mode of a song. There are two modes. There is a major mode and a minor mode. Major modes, they tend to convey a different feeling. For example, this is a song in a major mode. So this is from Opera Aida. This is Ramides coming back victorious after defeating the Ethiopians. Major modes, they tend to give a feeling of pride, happiness, and glory. While minor modes, they tend to give a feeling of solitude. For example, this is the music by Chopin. It's slow, it's sad, it's not that energetic. There are also features that describe the listening experience. For example, the energy. If you take music by AC/DC, it has high energy. Or if you take John Lennon, Imagine, it has lower energy. The artist is not really involved in the production of the song, in the performance. There are also valence, danceability, and so on and so forth. Now remember, I'm interested not only in the understanding the success of a particular song, but in the collection of songs and albums. And that's why for each of these features, I actually construct two measures. The first one is a central tendency, which is the average acousticness, or the average tempo that is contained in an album. And the second one is the variety. So I try to look how these features are varying across albums. To give you an idea of this, these are two albums. The one in orange is Sgt. Pepper of the Beatles, and the one in blue is All Eyes on Me of Tupac. So this is, let's say, pop music, and this is rap music. We see that in the average fingerprints, the rap music song album has higher energy, more danceable, and more explicit. It has more bad words or swear words. While the Beatles music is more acoustic, has higher modes, and is recorded with more audience in the recording. We also see that in terms of variety of the songs, and Sgt. Pepper's songs, they tend to be more varied in terms of valence, like the emotion, the acousticness, time signature, danceability, and so on and so forth. So these are the acoustic features. I also collected textual data, where these users or online users, they go and describe albums using just some tag words that they think that they would help them later retrieve the albums whenever they want to listen to them. For example, some of the tags or textual information that we find for Thriller of Michael Jackson are like dance or 80s or pop. For Adele, there's British soul, female vocalist. And for Taylor Swift, there is electropop, Love at First Listen, and so on and so forth. So now, as I showed you, I collected different data modalities. All these data, they have different natures from a mathematical perspective. Some of them are standard, some of them are continuous, and they are like representing the musical experience, and some of them are totally unstructured. It's text data. In order to account and correlate these measures with the success of the album, we built this machine learning model. Because it's the last session, we don't have time to go through the model. So that's why I'll just give you the figures. So I will show you exactly how we model each part of these data features. The standard covariates, let's say the genres. You see this graph here. Here we have the years from 1960 to nowadays. This is this axis. This axis here tells us how popular jazz was for these years. The model gives us, or the parameter, the estimate that we get is an entire process that goes up and down, telling us when jazz was popular and when it was not popular throughout all the years. For the acoustic features, we will use a non-parametric approach to model these. And I'll tell you why we use a non-parametric approach here. Can we tell if a high tempo is a good tempo or a low tempo is a good tempo? We don't know, or in the middle, we don't know. So we need the data to tell us where is a good tempo. And that's why we would model an entire function that would indicate the, between brackets, the ideal position of a good acoustic feature. For example, this is the average instrumentalness, the presence of acoustic instrument in an album. These are the years from the 60s to nowadays. This is low instrumentalness, and this is high instrumentalness. And basically, this curve here is telling us that for 1960, low instrumentalness was good because the function goes up, but high instrumentalness was bad because the function goes down. But as I showed you, or as we heard in the first experience, music, or the factors of musical success have changed over the years. And that's why we need to allow for these functions to evolve over time. And this is exactly what we do. Our model actually gives us surfaces. Oh, no, this is not working. Yeah, it gives us surfaces that tell us how these functions evolved over time. I will give you more details about these later. And also, we have unstructured data. We have lots of text, and we cannot account for all the text at once. And that's why we need a data summarization process. And that's why we use these themes. You can think about them as factors, the same as what Michel presented earlier. A theme will be a grouping of tags that tend to appear together. And instead of just allowing for 6 themes or 20 themes or 100 themes, we will let the computer tell us how many themes are there that really and truthfully describe the data. And then an album will have a thematic distribution, will have a thematic profile. I will show you what these means when I discuss the insights with you. So our model gives us actually very interesting insights about the evolution of music in the United States over the last 50 years. Of course, we get the ebb and flows of all the genres. We have 15, but I will just show you a few examples just to focus on these. For example, rock. These are the years from the 60s to nowadays. This axis here tells us the popularity of rock. We see that rock popularity increased between the 60s till the mid-70s. Music historians call this era the British Invasion. And this is a time where groups like the Beatles and the Rolling Stones became very influential and very successful in the United States. The peak here is 1972, and this is the year The Dark Side of the Moon was released. After that, rock music has been decreasing in popularity. So we heard lots of causal and structural talks this morning. This is not a structural talk, so I cannot say that this is a counterfactual. We cannot say that the Dark Side of the Moon caused the death of rock, but it could be. I can also share with you some of the results that we got on the acoustic profiles that are conveyed by the different albums. We have many of them, but I will show you just what we get for the average valence, or the average emotion that is contained in the music in an album, and the average energy, or the strength of the music that is contained in the album. Again, these are the years from the 60s to nowadays. This is low valence, that means negative energy, negative emotion, like sadness or disgust. And this is positive emotion, which means like happiness or excitement. And again, when the surface goes up, this means this is a good level. When the surface goes down, that means it's a bad level. What do we learn from this graph? It's telling us that for all the years, the best level for emotion, for success in music, are negative. That is, music or successful music has always been about negative emotion. It has always been about sadness and anger. Popular music, successful music is not Macarena or Despacito. It's really about sharing something that is dark with others. There are other aspects of the musical experience that have changed over the years. For example, the average energy. We see here, so this is low energy, this is high energy. We see that before the 80s, successful music was about high energy. Like you take music of AC/DC or rock music, it's really energetic. But after the 80s, successful music became about low energy. So it's more Adele, like soothing. If we combine these two together, we see that negative energy is always there. However, sometimes it's positive high energy or low energy. So high energy and low emotion, that's more anger. Low emotion and low energy, that's more sadness. So we could interpret this as going from a state of anger to a state of sadness in music. And again, this is not a causal model, or we cannot run counterfactual. So we don't know if it's our world is becoming more sad world. Who knows? Maybe the structural people will tell us what's happening. For the textual data, as I told you, we group the themes automatically, group the text automatically into themes that represent some aspects of the musical experience. For example, we get many themes. I will just share with you these 6 to give you an idea about what they mean. There are themes that relate to the mood of the consumption. This theme is about easy listening in classical music. There are some other themes that are more about reflective and energetic, bittersweet music. There are themes that relate to the situation of consumption. For example, beach music, Margaritaville, or Holiday in Christmas. And we get also other themes that give us more information that we did not have in our initial set of covariates. For example, the gender of the vocalist, female vocalist, pop, and love song, or the fusion of different genres. You take bossa nova and jazz, and it makes Latin jazz as a new genre that I did not have in my initial set of standard covariates. And again, we can show how a particular album has a thematic distribution, how these different themes are present in a particular album. For example, this is the second album of Adele, 21, and we see that it scores high on female vocalist pop love songs, the theme number 6, which is the indie rock of the 2010s, and sexy funk, funky soul. So now that I showed you how we could distill information from all these variables, how can we use them? What can we do with them? So we can actually score albums to see if they contain factors of success. And we can also use them to construct playlists. First, I will just show you how we can actually score an album. Because I have a dynamic study, I have 50 years of data, I can actually have retrospective views of different albums, or also future projections. Here, I took 3 albums that are contained in my data set, and I compute a score for them from the 60s to nowadays. And this is my predicted score of success. Here, these are the Sgt. Pepper of the Beatles, and we see that Sgt. Pepper of the Beatles is actually contains factors of success of the 60s, but doesn't contain factors of success of the 2010s, for example. Its score is always decreasing. Thriller of Michael Jackson does better. It has a kind of 20 years of congruency of factors of success of the music. But after the 1990s, its score goes down. My surprise was with Taylor Swift, 1999. In 2014, she produces this album called 1989. And then my success score is actually peaking in around 1990. When I went to the ABC magazine, she gave an interview, and they asked her about this album, and she said that she wanted to create something that resembles the music that was produced and successful in the years of her birth. And that's why she calls the album 1989. Well, my model is telling me that Taylor Swift did a really good job. We can also make recommendations that are based on the acoustic experience and also on the thematic experience. For example, let's imagine that I'm a fan of Thriller of Michael Jackson. Can I come up with an album? Can I be recommended an album that sounds like Thriller? Yes, we can, because we can compute an acoustic similarity score, and then we can order the albums that we have, and their decreasing order or decreasing similarity to Thriller. We find that I Feel For You of Shaka Khan is very acoustically similar to Thriller. We can also recommend albums that are thematically similar to Thriller. And we find that, for example, Invincible or Control or Simply the Best of Tina Turner, they have or exhibit a very thematic similarity to Thriller. That is, they are maybe consumed for the same situations, or the fans that really like these albums, they tend to describe them and categorize them using the same words. Finally, we can use the parameter estimates or the model's result in order to compile playlists. And as I told you before, different generations of listeners, they tend to like different types of music. What I did here is I collected all the songs of Adele in her first album, 19, her second album, 21, and third album, 25, and I tried to come up with 2 playlists of 5 songs. Each one of them would exhibit the best success score or the best appeal for a population of 1973. So these people would be about 60 years old now, and a population of 2016. I also collected the best top 5 songs of Adele as judged by music experts of the Billboard. There are 2 learnings that we get here. The first one is a good playlist is not necessarily the one that contains all the good songs, because we can see here that these playlists here don't necessarily have all the best songs of Adele. The second learning is the 2 playlists are different. They contain different songs. The songs of the 1973 playlist are very different from the songs of the 2016. And actually, that's because they exhibit different musical characteristics. For example, the orange one is the 1973 playlist, and the 2016, the blue one is the 2016 playlist. The 1973 playlist has higher keys on average for its songs, has higher energy, higher modes, while the playlist of 2016 can exhibit, for example, higher variety of modes or higher variety in the acousticness, the presence of a guitar in these songs. So basically, this is my work on dynamics of musical success. I showed you that we can actually extract musical information and build a model that can help us understand success of musical albums. We also derived insights about musical trends that happened in the history of music, and we showed that we can actually leverage the model results in order to help artists construct new albums and also construct playlists for different people of different tastes. As you can see, the model is used for music, but it's more general. It can be applied to different types of products. It's really about extracting some experience of the consumer and then quantify it in order to serve them better. Thank you very much. Yes.
So really interesting talk. I'm wondering, it seems like music is like one of the defining parts of it. It's the interaction between the parts. And I'm wondering if your model, or if in other models that you've run, has tried to account for the interaction between different facets. So like energy and instrumentality, for instance.
Yeah, so in this model, I do not account for interactions. It is very possible to account for them, except that the model becomes untractable, because that creates, we have thousands of variables. To account for all the interactions, it becomes very hard even for the computer to compute these. But maybe with some new technological developments, we could, absolutely. Yeah.
Or you could potentially like sample out like, okay, these 5, like by talking to music experts, seem to like go together and have these really multiplicative
Absolutely, of course.
impacts.
Yeah, or we can use actually some of the data selection, like lasso or ridge techniques to find what are the interactions that really matter. Absolutely. Yeah. All right, well, thank you so much.